Hello, good afternoon. My name is Ramiro VALDÉS
Yeah, we can hear.
from Cantos, Spain, and today I've come to present my project to you, Transition to Photovoltaic Solar Energy in IES Pintor Antonio López, Tres Cantos. So first, we will talk about the objective of the project and the causes that led me to do it. Next, we will move on to the photovoltaic project, carrying out an analysis from 3 points of view, technical, financial, and environmental. Next, we will study the business opportunity presented by the photovoltaic project, as well as a simulation of a private company and the generation of profits. And finally, the conclusions that I obtained based on this project. So, the objective of this project is to demonstrate the technical and economic feasibility of implementing a photovoltaic installation in a school. So the reasons that led me to do it were, first of all, as we all know, global warming is considered the most important challenge, and for this reason society requires an energy transition, betting on renewable energies. So the project is in the city of Cantos, which is about 30 kilometers from Madrid, Spain. The coordinates are important as they will determine the solar quantity received in the location. We will move on the photovoltaic project. The current Spanish photovoltaic regulation resides in Royal Decree 244/2019. It includes modifications such as administrative simplification and especially the annulment of the sun tax. In addition, a compensation system is introduced that allows surplus energy to be poured into electricity grid. Then, moving on, an analysis of a current electricity bill is performed. Then, the electricity bill is contracted with hourly discrimination, so that 3 billing periods are different during a day, being night period, valley, which is the cheapest period. Then, among the most important terms of electricity bill, they are the fixed part, which is the power, the amount of energy that can be used in a specific time, and the variable part, which is the consumption we do. So making making an estimate in which the monthly bill is constant, the total annual expenditure on electricity bill is 3,200 euros. So moving on, to carry out a photovoltaic installation, it is vitally important to know the amount of solar energy in the location. For this, I use the PBGIS application, which is a satellite geographic information system, which allows knowing the solar irradiance at the project location. Then, the inclination of the photovoltaic panels depends on the position of the sun. So, at the location that we're making this photovoltaic installation, the optimal angle that maximizes the solar resource obtained is 36 degrees, as we can see at the right. But during the winter months, it presents a much greater difference than the summer months. So more energy would be needed from the grid in winter, or there would be a lot of energy left produced in summer, which one we use. So if the cell price is lower, I decide to use a 50-degree slope, which, despite having less annual solar resource in total, favors the obtaining of energy in winter months and does not produce excessive surpluses in summer. Also, there are some photovoltaic panels that follow the path of the sun, but their high cost would mean a decrease in economic profitability, so I decided not to implement them. There are 2 types of photovoltaic installations: isolated installation, not connected to the electricity grid, and the grid-connected ones. And due to the high cost of batteries and their legal changes, I decided to use the grid-connected installation. Then, to select the elements, my elements were based on the company Autosolar, just as reference, and through estimates that the center consumes around 270 kilowatt per hour during the elective days, the school days, I chose a kit which requires an initial investment of 48,000 euros, and it has 25-year warranty, which will be the duration of the project. Then, in the graph, we can see the productions of the photovoltaic kit. The red line delimits the consumption of the center. Based on the production shown, the resulting electric bill after application of the photovoltaic installation is divided into 2 blocks: the months that do not require electricity supply from the network, months close to summer, and those that they do. So in the winter months, the fixed part will be higher and the variable part as well. Adding up all the monthly bills, we can conclude a yearly saving of 10,000 euros, which is produced in the electricity bill compared to the previous one that I showed. So for evaluating a project, I used some economic criteria, which were the net present value, which consists of updating receipts and payments of a project, and in this case the interest rate used is 5% and the period is 1 year. So when the net present value is greater than 0, it indicates that the investment generates benefits. The internal rate of return, which is defined as the value of the discount rate that makes the net present value equal to 0, and if this internal rate of return is greater than the discount rate, in this case 5%, the project exceeds the minimum profitability required. Also, I used ROI, which is return on investment, allows you to know how much of each euro invested in a project has generated in sales. If it's very close to 0, profitability would be minimal. So as greater as it is, the best. And then finally, the payback. Payback or recovery period is defined as period required to recover the initial capital of an investment. So logically, an investment where the recovery period is shorter will be preferable. To analyze the profitability of the photovoltaic installation, the duration of project 25 years and the initial investment required of 48,000 euros must be taken in account. So the cumulative gain with an interest rate of 0% without the net present value is represented by the blue columns, and on the other hand, the benefits are applying the net present value is 142,000 euros. So the internal rate of return is 23.86%. It's a high profitability, almost 5 times the one used. The ROI and payback indicate a return of almost 300% on each euro invested, and the date from which the investment has been recovered, profits began to be generated. It is 1/5 of the duration of the project. So after having analyzed these economic criteria, it is concluded that the project is profitable. Now, the possibility of oversizing the photovoltaic installation is also considered. For this, it would be needed a 20 kV kit added to achieve the energy consumed annually during all months of the year, as you can see in the graph in the left. This leads to a higher annual saving of $300,000. After performing the calculations, we obtain an increase in profits of $16,000, but almost $16,000 have to be invested to purchase the kit. So the internal rate of return is close to the one used, which would mean a decrease in profitability and a high financial risk. So it was decided not to oversize the installation. Now we're going to analyze the environmental impact that the transition to photovoltaic energy would entail. Currently, in a period of 25 years, the center consumes 2,120,000 kWh, which represents 869 tons of CO2. But if we use the photovoltaic installation, we would save 632 tons of CO2. So this figure is equivalent to 5,300 trips by Madrid-Barcelona in car of one passenger. So now we're going to analyze the private company simulation. After the completion of the photovoltaic project, a business possibility is observed, because despite its high profitability, it is an investment that requires a costly initial investment. So after studying the economic regulations that govern public centers in the Community of Madrid, due to the difficulty of indebtedness of a public entity, the idea of creating an intermediary private company was born that would offer the center the possibility of a transition to photovoltaic energy. The center is offered a percentage discount on the electricity bill for a period of 25 years, which is the duration, at zero cost for the center, and then the company would share would charge the energy consumed to the center, applying the tariff terms of its electricity company, explained above, with a discount, which would increase progressively over the 25 years to reduce the financial risk of the investment. As an example, the high school Pintor Antonio López is used. A 10% discount is offered that will generate an approximate savings of 43,000 euros. So in exchange, the center has to allow the company the possibility of implementing the photovoltaic installation. The benefit is twofold for the center. On the one hand, the center reduces the monthly cost of its electricity bill, and on the other hand, by using green energy, it will benefit from an improvement in its image with regard to environmental policies. So the profits of the company come from the profits produced by the photovoltaic installation, discounting, in this case, the 43,000 euros saved by the high school. So, the selected financial criteria show profits of 99,000 euros and an internal rate return of 15.5%, which is 3 times the minimum required return. Therefore, it is concluded that it is a profitable project for the company. Finally, the conclusions. So we set ourselves as an objective for this work the hypothesis of demonstrating the viability of the transition to photovoltaic energy in the IES Pintor Antonio López. Regarding this, it can be concluded that the project is technically and economically viable for the following reasons. The technology of photovoltaics has experienced a big evolution, making it easier for such projects so they can have benefits in the short term. And in addition, the unquestionable repercussion favoring the medium environment and reducing the CO2 emitted into the atmosphere. Also, changing the regulations of consumption energy in April 2019 has benefited the viability economic of the project, since its numerous changes that introduced. However, there have also been some limitations, such as the difficulty of having consumption of the center in time slots. It would have been convenient to have a meter in the electrical network to know hourly consumption. In this way, the calculations made would be more precise and the error rate would decrease. Also, I would like to add a final thought. I would like to highlight the importance of an economic and financial analysis in the evaluation of long-term technical projects. So, thank you for listening to me, and also to the contest for having selected my project. Thank you for your attention.
Thank you for your presentation. Any questions from our experts?
Yes, I have a question. The main question, what is the result of your project? Could you conclude?
Excuse me, can you repeat?
What is the main result of your project?
So, I would highlight the main result of this project is to show that it is possible that, in this case, high schools and all buildings of a government, such as high schools, it could be another thing, that they can have the possibility with a creation of a company to have a solar resource instead of consuming CO2 and giving more CO2 to the atmosphere. The result is to show that it is possible and it is also profitable, economically talking, you know. So that is the main result I want to show.
I have a question. Thank you for your presentation. Can you explain if you are intending to completely use solar system for powering those buildings that you've mentioned, or you are planning to have a mixed hybrid grid and the solar?
Okay, so I think that was my fault that I didn't make myself clear in the video, but I was looking for the best profitable option because I have two options: the network connection by also using solar panels, and the only ones that and another possibility that was only using solar resources. But in terms of economic profitability, it was better since batteries have a high cost to use a solar resource, but as well be connected to the network. So in this case, the result would be a hybrid method.
So if it's a hybrid, then at any given time, how would you ensure that the green energy, so to say, is used? Is there any way that you can monitor or, for example, create some kind of data process that will basically mark the green energy that you are generating, as to compare to the one that you will be getting from the grid? How will you differentiate between the energy source?
So these solar kits of those companies, they are programmed, I mean, to use at every moment, if they have the possibility, the green energy. So if you are connected to the network and you don't have enough green energy for a specific moment, that's when they start to get the energy from the network, and that would mean an increase in the electricity bill. But otherwise, if it was possible, that was the possibility of oversizing the photovoltaic installation. They wouldn't use network electricity at all. So the solar kit is programmed itself to use green energy whenever it's possible.